Hello and welcome. My name is John Haskell, go by JT. I'm going to be your instructor for this course. And what we're going to go through over the next few chapters is Introduction to Automation and our toolkit. So as we go through here, what we're really trying to focus on here is not really making sure that you're a full-time programmer. That is not this course. What I rather do is try to get you to understand what is automation, how are we going to use it as an IT professional, where are we going to see it in our day-to-day job, and then if I do get code from artificial intelligence or machine learning or GitHub or from a quick Google search, do I know what that code is doing before I put it into my production environment? So today, let's go through chapter 1. So again, chapter 1 is all about the big picture. We're going to be talking about the automation. We're going to talk about our toolkit that we're going to utilize throughout this course. Now, automation is a powerful thing that we do in all of our IT experience. And to be honest, I like to say automation is what helps IT be lazy. And I try to joke about that quite a bit because the more we can automate, the better we are at our jobs. For one, we won't have human error. Human error goes out the door. But the other thing is trying to get us to understand how to use automation responsibly. Because automation itself, while strong and as great as it is, can also cause a lot of havoc in the system if not properly tested or implemented within an organization. So what is automation? Well, it's a way that we use technology to perform all the tasks that a human would do. And what we're trying to do is we're trying to provide minimal human intervention or minimal human assistance. For instance, instead of a human going through a task and renaming last name, comma, first name in a file 1,000 times over, why couldn't we use automation to do this task for us? And the answer is yes, we can do automation and we can use automation responsibly to do this task. Now, how do we come up with the script? Well, we'll have different methodologies in how we do that throughout this class, but just so you know, this class is going to be focusing on Bash, PowerShell, and Python. Okay? So between those three languages, we'll learn how to use automation. Now, we won't just be using scripting along the way, we'll be trying to use microcontrollers as well. Now, the automation lifecycle is our fundamental cycle that we'll be going through. And so the first thing we need to do is we need to be able to sense the condition of the environment. Now, in this slide, I mentioned that it could be temperature, motion, or even a button press. These are all like physical activities of using a microcontroller. And while this is a lot of fun, and yes, we are going to do it this way, we also will be sensing information through data itself. The data itself is also the way that we'll sense information. Once we have all that information, we need to interpret what it means. If it's 60 degrees in the office or 105 degrees in the office is two totally different things. And how do we understand what we're going to use with that data? So we're going to process this data. And for those who have not gone through the CompTIA Tech Plus certification program yet, which I do highly recommend that you go through if you're going to get into technology, it goes through a process called IPOS, Input, Processing, Output, and Storage. And so while we still do a lot of that, what we're doing here is we're going to be sensing the data, we're going to generate the data, we're going to process that data to make it more human relatable, and then we may act upon the data. Now, remember with automation, we're trying to do minimal human assistance or human intervention due to the fact that, well, we don't want to get woken up at 2 o'clock in the morning as an IT professional. We love our sleep. So we're going to have the system be able to either auto-recover or back up files or do these tasks that a human can do, but a machine can do it so much better. So again, why are we automating? Efficiency. As I said, they're better than us in a lot of ways. And so can we perform the task better and without error? So are we reducing errors? Well, that's accuracy and consistency. Accuracy and consistency is something that will help us reduce those errors. And then lastly, like, we're looking at safety. Sometimes these tasks need to be automated because humans are prone to errors. If it's something like it needs to complete a task, otherwise the tank explodes, well, we're going to need to have safety in mind, and automation will definitely help this. Convenience is just to try to simplify those overly complex or repetitive tasks. Okay, those complex tasks could be something that's just, it's very easy for a human to mess up, or repetitive tasks is those 1,000 names that we had to put in that file. Well, it would be so much easier if we just let a computer do it for us. So, as I said, what we're going to do in this course is we're going to then bring in microcontrollers and scripting and marry the two. We're going to be using microcontrollers as our hands, as our senses. We're going to be looking at things in the environment like maybe temperatures, or we're going to sense motion through a motion sensor. And then we're going to take that information, we're going to process it, and we're going to process it and do something with it. Well, how do we process it? It's going to be scripting. It's going to be the brain. It's going to be our coordinator, and they're going to process information, make sense of it, and then do a task at hand. So for those who have never touched a microcontroller in the past, a microcontroller are tiny. They're dedicated computers on a single chip. They are a bridge between a digital world and the physical world. Okay, the digital world of code is zeros and ones and a lot of software, while the physical world is normally real-time controlling, sprinkler systems or lights or anything that is basically going to interact with us in the human physical world. So the first microcontroller that we're going to see in this course is you're going to see the Arduino Uno. And actually here in Chapter 1, our final lab is going to be using the Arduino Uno to make a very simple Blink program. Mainly because this chapter here is we're going to try to get you to just get your environment set up. Set up some of the software that you need to complete, and then we'll start utilizing it. So the Arduino Uno is the very first microcontroller that I like to use for this course, and it's great because it's great for beginners. Okay, now it does have all the same concepts as any other microcontroller out there, but it's a great way to start getting into scripting without diving in too far. But once you're done with that, we will move on to what we like to use as an ESP32. An ESP32 is another microcontroller, and it's actually a lower cost microcontroller. And these microcontrollers are nice because they have additional capabilities. We'll be talking with Wi-Fi, Bluetooth, and we'll be programming a lot of things in Python at this stage. So what you'll find a lot of these devices in the real world is you're going to find these in a lot of IoT devices, Internet of Things. Your smart thermostats, your smart locks, your motion sensors for your security systems. All these things are called IoT devices. No longer can we go around and even buy a fridge now that's not a smart fridge, or a microwave, or a stove. All these devices will be useful and utilize different microcontrollers as we go. Now the software, as I said, is going to be the brain of our automation. This is where we're going to bring in logic. This is where we're going to learn how to do pseudocode and handle all that data. As we start going through this, we'll even go even more complex things like networking. Networking is a complex topic, but to be honest, is within your grasp. Within the next 16 weeks, if you take this course at an institution, or within your own time frame, you will find that this software scripting section is where it starts becoming more fun, because you're starting to utilize the technology in a way that you never thought was possible. All right, so our toolkit is going to be Python, Bash, and PowerShell. Okay, now Python is extremely versatile and is well known in the industry. Okay, we like to use this as a general purpose language. It's not only made for scripting, it can be made to program large applications, but is also one of those languages that if you can learn how to use Python, you can learn to program in any language out there. Now we're also going to use Bash and PowerShell, mainly because Bash is what you're going to find in Mac and Linux, and you're going to find PowerShell in Windows. So covering these two bases will allow you to live off the land. In other words, have the software that's already developed in these operating systems we use every day. 94% of all web servers out there still run Linux. Linux is the main server for many of these services out there. Now, Windows still is going to be the major utilization for desktops, but you're going to find Linux and servers, and you're going to find Windows and desktops. Now, as a system administrator, you're still going to need to be able to control those desktops and manage those desktops. Now, if you only have a handful of servers and computers, they're pretty easy. But what happens when you start having thousands of Windows or thousands of Linux machines out there? How are you going to manage those when you're an IT team of one? So we're going to use different tools like our breadboard. And so we'll go through the breadboard in the next class, but just know that we're going to be using the breadboard for prototyping. It's a plastic board with a grid of holes. Now, I do highly recommend that if you've never used a breadboard before, throughout this course, I will be providing additional videos, but also go through the book material. In the appendix, you'll find there's a whole section on just breadboards. These breadboards are definitely going to be utilized as you go through this book, and because we're not going to want to solder things. Soldering is great, but it also makes permanent circuits. Breadboards allow us to do temporary circuits. It allows us to play before we decide our final technology. We're going to use a lot of inputs and output tools. Input tools like sensors. These could be like, well, push buttons or photoresistors or thermostats. Inputs are just anything that's going to interact with the real world and bring it into the digital world. We're going to then deal with outputs, which could be actuators. You'll see the word actuator quite a bit, and they don't mean actuators as things that move, but also can interact with the real world, where we could say, turn the LED on, turn the LED off, turn the motor on, turn the motor off, sense if there's motion, start playing a sound. Anything that is interacting with from the digital world to the output world, to the physical world, is an output device. Okay, so anything that's taken from the real world to a digital, we're talking input, and anything from the input to the physical world, we're talking about an output. Now, our software environment that we're going to use, and this is the section that we're going to do for Chapter 1 for sure, is I want you to be able to install the software that you need to complete this course. So one of the pieces of software is going to be Arduino IDE. We're going to use things like VS Code and Thonny for Python, and then we'll also be using things like Git. So the Git repository as well. How do we save all this code and the scripting that we do? We use a Git repository. The Git repository will allow us to share it with the world or keep it private, but keeps it backed up from just being a local copy of our code, which is, well, as we all know, things can happen. What if your laptop breaks or gets destroyed? What happens to all the data on the hard drive? Is it still there, accessible, or did you have a backup of it somewhere else? Now, before we get too far into electronics in this course, I always like to mention safety first. Make sure that you adopt safe practices. For instance, make sure you unplug the device before you start moving wires. If it's on, you shouldn't be messing with the wires. Unplug the device. And this is more for the safety of the devices than it is for your own safety. Most of these devices that we're going to be messing with in this class are 5 volts or less. They're going to run off of mostly USB, and as great as that is, it really isn't going to shock you. What we're looking for here is we just don't want to destroy all of our fancy hardware that we bought, so we want to make sure safety first. Let's make sure that we protect ourselves as well as our Arduino Unos and our ESP32s, because we don't want to burn them out and have to get another one. Okay, so make sure that you're unplugging your stuff, and then also I always try to recommend make sure that you're using a surface that isn't going to conduct electricity. For instance, I like to use rubber mats or grounding wires to make sure that I'm not wearing socks and walking across the floor and getting a static shock to my devices, because that's the easiest way that you're going to kill the device and, well, it's going to be a paperweight at that point. So, disconnect your power first, check. Check your wiring, okay. Mind the polarity. As we go through things, I will tell you about polarity, like LEDs must be connected in the correct direction, otherwise they just don't work. But the beauty of them is a lot of these devices won't be burnt out because you plug them in incorrectly, okay. And then lastly, as I said, no socks across the carpet because you're going to be shocking your devices. Key safety rules. All right, so that's chapter 1. Make sure that you read through all the book material. Make sure you go through the activities, and then make sure that you take some time and actually do the lab. So this class here is a great class to take some time and learn. Just try to understand where you're coming from, because without playing with the electronics, book knowledge isn't going to do you so much. So make sure that you learn about something and then play with it. And also, I am not against the use of artificial intelligence. If you need to use Gemini or ChatGPT, go for it. Go for it. What I'm looking for here is to see if you can learn. Are you able to then go through all of these courses, go through all this material, and then at the other end, learn that, hey, I can read code. I can go through this and make sure that I don't break my production environment. Now, as we go through with automation, it's going to be fun. We're going to do a lot of cool things, but just make sure that you're tying this back together with your IT profession, as the automation section of this course will aid you in your career search. Okay, so I will see you for the next video, and good luck with you installing all those software. Remember, use those appendix, use the book. It is going to be very helpful as you go through this course. See you next.